So, this project describes an automatic rain-sensing clothes cover system that's designed to protect clothes hung outdoors from sudden rain. When rain is detected, the system automatically deploys a waterproof cover using a motorized actuator that's controlled by an Arduino microcontroller. This whole setup improves convenience for households, reduces manual intervention, and can be adapted for different configurations and scales. The objectives here are, first, to detect the onset of rain reliably using a rain sensor module. Next, to automatically deploy or retract a protective cover over clothes using a motor and drive mechanism. And finally, to provide a low-cost, easy-to-build system that's suitable for typical household use. All right, here's what you'll need. One Arduino Uno, which is an ATmega 328P-based microcontroller board. You'll also need one rain sensor module, which gives you analog or digital output. Then, either a servo motor, at least 5 kg/cm torque, or a DC motor with an L298N or H-bridge driver, just one of those. A 5-volt power supply or regulator for stable power to the Arduino and sensors, again just one. For the frame and rolling mechanism, you'll want some aluminum or wood for support, and a spool, just one set. The waterproof cover material can be tarpaulin or PVC sheet, one piece. And finally, you'll need assorted wires, connectors, and screws, just one set. Basically, here's how the system works. It uses a rain sensor that provides an analog or digital voltage that's proportional to moisture. The Arduino keeps reading the sensor value on an analog pin, usually A0. If the value drops below a certain threshold, which means it's raining, the Arduino drives the motor, either by PWM or a direct servo command, to unroll the waterproof cover. When the rain stops and the sensor value goes back above the threshold, the Arduino retracts the cover. It's pretty clever, actually. All right, let's talk about the circuit and wiring details. So, for the rain sensor, you connect the VCC pin to 5 volts, the ground pin to ground, and the analog output to A0 on the Arduino. For the servo motor, the signal wire should go to D9, which is a PWM pin, and you get power from the 5-volt supply. Just make sure that the servo supply can actually handle the current. Now, if you're using a DC motor, you'll need a motor driver, like the L298N, or maybe a MOSFET with a diode. The driver input pins should be connected to Arduino digital pins, such as D9 or D10, and the motor gets its power from a separate supply if that's needed. Oh, and don't forget, a common ground is required between the motor supply and the Arduino. Moving on to the mechanical design, the cover can be rolled onto a spool that's connected to the motor, kind of like a roller mechanism. It's best to place the clothesline right beneath the path where the cover travels. Use bearings or smooth axles for the spool so you can reduce the load on the motor. You should also provide limit switches, or maybe measure the current or use encoder feedback to stop the motor when the cover is fully rolled or unrolled. This helps avoid any kind of damage. And of course, make sure to weatherproof the electronics by placing them inside an enclosed box with proper ventilation and waterproof the exposed connectors. So let's get into the Arduino programming part. You'll start by including the servo library. For the hardware connections, the rain sensor's analog output goes to A0 and the servo signal wire goes to D9, or you can use those pins for the DC motor driver inputs. Power everything with 5 volts and make sure there's a common ground. You'll declare a servo object called cover servo, set rain pin to a 0, and define a threshold value, like 600, which you can adjust after some testing. Set servo cover pose to 160 for the deployed position and servo retract pose to 10 for the retracted position. In the setup function, you'll start serial communication at 9600 baud. Attach the servo to pin 9, move the servo to the retracted position, and set rain pin as an input. Then, in the loop, read the sensor value from rain pin. Print it to the serial monitor and check if the value is less than the threshold. If it is, that means rain is detected, so you deploy the cover by moving the servo to the deployed position. Otherwise, you retract the cover. Finally, add a delay of 500 milliseconds, so you're sampling about twice a second, but you can adjust that as needed. Alright, let's move on to testing and calibration. First, we'll calibrate the threshold. So, use the serial monitor to observe the analog values when it's dry and when there's light rain. Then, set your threshold somewhere between those values. Next, let's verify the motor movement. Test the servo endpoints, and if needed, add mechanical stops or limit switches to avoid any overrun. Now, for power considerations. If you're using a DC motor, make sure to use a separate power supply, like a 12-volt battery, and a regulator for the logic 5 volts. And yeah, don't forget to ensure a common ground. Finally, do some environmental testing. Test the sensor placement so you can avoid false triggers, like from splashing water versus continuous rain. So when it comes to safety and maintenance, it's really important to ensure waterproofing of all electronics and connectors. You definitely want to avoid exposing motors and drives to direct water, unless they're properly protected. It's also a good idea to periodically check all the mechanical mounts, screws, and cover material for any signs of wear. And yeah, if you're using AC mains powered supplies, always use proper fuses and protection to stay safe. Thinking ahead, there are some cool enhancements and future work you can consider. For example, you could add Wi-Fi or Bluetooth to receive notifications, or even control the system remotely. You might also want to use a small anemometer or wind sensor, so the cover doesn't deploy during high winds. Measuring rain intensity and using partial cover strategies could make the system even smarter. Adding solar power would help if you want off-grid operation. And finally, implementing encoder-based feedback would give you much more accurate control over the cover's position. To sum up, the automatic rain sensing clothes cover system is a practical, low-cost automation project that really demonstrates real-world sensor actuator integration using Arduino. With careful mechanical design and proper calibration, it offers a reliable solution to protect your clothes from unexpected rain. If you're looking for more information, you can check out the Arduino official documentation at arduino.cc for details about the board and libraries. For rain sensor modules, have a look at the product datasheets for pinouts and calibration details. And for motor drivers like the L298N or MOSFET, the datasheets will help with wiring and power considerations.